Question 21. ABCD is a parallelogram. ABP and QDC are straight lines. Angle ADP and angle CBQ is 90. Prove that triangle ADP is congruent to CBQ. So, to prove that they're congruent, we're going to have to try and find whether they obey any of the congruency rules. So, for this triangle, we'll call that BQC, and we'll call that DAP. Okay, so this is the parallelogram that both of them form. So we can see that this length here, AD, must be the same as BC, because they are two sides of a parallelogram. So we'll say that BC must equal AD. Okay, now we also know that this angle here, I'll use a different colour, we'll call that X, must be the same as this angle here, which means that this angle here must be the same as this angle here, as opposite angles in a parallelogram are equal. And finally, we also know that this angle here and this angle here are the same because they're both 90. It's a right angle triangle, which means that we have angle, side, angle. So they must be congruent because they have angle, side, angle. So these two triangles are congruent as ASA. Okay, part A. Part B. Explain why AQ, let's rub out my workings previously so we can fully appreciate the initial diagram. Explain why AQ is parallel to PC. So let's draw AQ here and PC here. Now, AQ and PC must be parallel because AP and QC must be the same. AP and QC must be the same. They must be equal because these triangles are congruent, which means that length is the same and that length is the same. This means that AQPC forms a parallelogram. Because it forms a parallelogram, AQ and PC therefore must be parallel if they are in a parallelogram. And that is the end of the paper.